In this video, we're going to do the following problem. Simplify. Assume that the radicand was not formed by raising negative quantities to even powers. And the problem we're given is the square root of 8c all raised to the 6th power. So we could rewrite this as the square root of 8 raised to the 6th power and c raised to the 6th power. And since we're taking the square root, we want to look for pairs of factors. So we could rewrite this as 8 squared times 8 squared times 8 squared, because here we have 2 factors of 8 times 2 factors of 8 times 2 factors of 8, giving us that total of 6 factors of 8. And we could do the same with the c. C squared times c squared times c. And again, here we have 2, 4, 6 factors of c, giving us a total of 6 factors. So this is equivalent to the original. And we can now rewrite this as the square root of 8 squared, the square root of 8 squared, the square root of 8 squared, times the square root of c squared, the square root of c squared, the square root of c squared. And now here's where we'll remind ourselves that the problem told us that we could assume that the radicand was not formed by raising negative quantities to even powers. So that means that as we evaluate these, simplify these, we don't need to worry about using absolute value notation. Now the square root of 8 squared, that's asking us for the number that we need to multiply by itself in order to get 8 squared. And that's 8, because if we multiply 8 by 8, we'll get 8 squared. And so each one of those first 3 radicals is equal to 8. And the same is true with the square root of c squared. It's asking us for the expression that we can multiply by itself in order to get c squared. And that's c, because c times c will give us c squared. So we get c times c times c, and this gives us 8 cubed times c cubed. Now I'll move this up a bit. And if we multiply 8 by itself 3 times, we get 512, and the c cubed stays c cubed, and that is our final answer.